not all concentrations, as we saw in that experimental data, drop exponentially. That means if I'm here, as time progresses, I don't mean exponentially, I'm sorry, in a linear fashion. That doesn't mean that as time progresses in these intervals, that the concentration is going to be proportionate. Not all reactions do that. Some reactions do this, that it's proportionate as the interval, the time goes and continues, that the concentration is in a line like this, right? A straight linear line. Some concentrations decrease like this. Some just a little slow, like this. So what we have, depending on the concentration or the graph, this has to be done experimentally. You will not know unless it's told to you or you see the experimental data for yourself what type of reaction you have. So we're going to talk about today 3 types of reactions. All right. We have what's called a 0 F order, a first order, and a second. There are more, but today we're just talking about these 3. A 0 order experiment means I don't care about the concentration. The rate of this reaction is equal to just the rate constant, K. It means you can add more and more and more or less and less of your reactant, and it's not going to change how fast the reaction happens. It's going to happen at this rate constant regardless of what you add. Right? A first order reaction is the rate is equal times to the rate constant times the molar concentration of a specific reactant. Because you can have multiple reactants in a reaction. A second order reaction says rate is equal to the rate constant to either A squared or K times A times B, where they both play a role in the reaction. So listen very carefully to this terminology that I'm about to say, okay? This rate order right here is first order in A, because there's a 1 here, first order in A, and first order overall. Look at this one. This rate order is first order in A, first order in B, because assume there's 1s here, and second order overall. So when you determine rate order, you have an overall rate order where you have to take them all into consideration. And then you have an individual rate order in regard to that specific reactant. Because both reactants don't have to form reaction products in the same order. Versus overall, it depends on everything. You can have the rate equal to that. which means, sorry, that, which means, what is this? Which order? 0. So this rate is 0 order in A and 0 overall. It's a 0th order reaction, which means that the rate has nothing to do with the change in concentration and only matters on the rate constant.